Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Today we'll be looking at electrolysis. So our lesson objective for today's lecture is we're going to look at the definition of electrolysis. We're going to describe the electrolytic cell. Then the three is predict the identity of substance liberated during electrolysis from the state of electrolyte, whether in molten state or in aqueous solution. Then we're going to state and describe the factors affecting the preferential discharge of ions during electrolysis. So please, I want us to pay attention and get the best from today's lecture. Thank you very much. So electrolysis is coming from two major words, electricity and breaking down. So the lysis means when to break down, breaking down. So electrolysis simply means decomposition by electricity. When you break down a substance into its component using what? Electricity. So electrolysis simply means decomposition by electricity. So it is passing an electric current through ionic substance that are molten or in aqueous solution. Then it will now break them down into what? Into elements. So the process is known as what? Electrolysis. And the substance that is broken down is called what? Electrolyte. What is an electrolyte? It's a substance that conducts electricity in solution or what? In molten state. You know, when the substance is in solution or in molten state, the ions are free to move. When ionic compounds they are in solution or in molten state, we get what? Electrolyte. And at that point, the ions are free to what? Are free to move. So this is substance that conducts electricity in solution or in molten state. So generally, electrolysis can be defined as the chemical decomposition of an electrolyte into its component ions or element by the passage of what? Electricity through it. So it's as simple as what? A, B, C. So when an ionic substance is melted or dissolved in water, the ions are free to move about within the liquid or solution. It is at that point that it can conduct electricity. But when the ionic solid, when it is in its solid form, what happens? The ions are not free to move, so there's no conduction of electricity. At that point, it cannot act as what? As an electrolyte, because the ions are not free to move, so there's no way for conduction of electricity. But this molten, the ions will be dissociated into the ionic compound will be dissociated into its component ions, which is positive and negatively charged ions, and the ions are free to move. So because it is in molten state, so electricity is conducted. At that point, it can act as what? As an electrolyte. So when solid, the ions are not free to move, so no conduction of electricity. But when water is added to it, it becomes an aqueous solution. So when dissolved in water, the ions are free to move. Electricity is conducted, so it can act as what? As an electrolyte, so it can conduct electricity. So we say electrolysis is the chemical decomposition of an electrolyte into its component ions by the passage of an electric current through it. So it must be in what? In its electrolytic form. It must be either in molten state or what? In solution, in aqueous solution. So that is when the ions are free to move, and that is when it can conduct electricity. So electrolyte is any substance that conduct electricity either in solution or in molten state. It is when it is in solution or when it is in molten state that it can conduct electricity, because it is at that point that the ions are free to what? Ions are free to move. So we're looking at an electrolytic cell, which is the apparatus where electrolysis takes place. What's an electrolytic cell? Electrolysis takes place in an electrolytic cell. What's an electrolytic cell? An electrolytic cell is an assembly of two electrodes dipped into an electrolyte and connected to a source of electric supply, which is the normal primary cell, which is a battery, which is direct current power supply. So you can see the two electrodes, the positively charged electrode and the negatively charged electrode. This is the positive electrode. This is the positive electrode, which is the anode, and this is the negative electrode, which is the cathode. This is the source of electric supply. These the electrolytes. Electrolyte, the substance that will be electrolyzed. When you pass electric current through, the electrolyte will be decomposed into what? Its component ions. So electrolysis takes place in an electrolytic cell. Just as I explained, that it's an assembly of two electrodes, anode and cathode, deep into what? An electrolyte and connected to a source of what? Electric supply, connected to a battery that supplies what? Electric current. So that it's as simple as ABC. So when electric current is passing through a solution of an electrolyte, electrolysis takes place. What happens? The electric current dissociates what? The electrolyte into its component ions, positively charged ions and negatively charged ions, because we're dealing with an ionic compound. An ionic compound consists of an aggregate of oppositely charged ions. So what happened? By the time you pass electric current through it, it dissociates into its component ion, the positively charged ion, which are the cations, and the negatively charged ions, which are the anions. So during electrolysis, the positively charged ion, which is the cation, migrates to the negative electrode, which is the cathode, gains electrons and become reduced. So reduction takes place at the cathode. The negatively charged ions, which are the anions, they migrate to the positive electrode, which is the anode. They lose electrons and become oxidized. So oxidation takes place at at the anode. So the reaction that takes place in an electrolytic cell is what's called redox reaction, because an electrolytic reduction and oxidation takes place. Reduction takes place at the cathode and oxidation takes place at the anode. So at the cathode, the positively charged ions migrate to the cathode, gains electrons and become reduced, and at the anode, the negatively charged ions migrate to the anode, where they lose electrons and become oxidized. So reduction takes place at the cathode and oxidation takes place at the anode. So the entire reaction that takes place in an electrolytic cell is a redox reaction. So an electrolysis is a redox process. It's a redox process where reduction and oxidation takes place at the same time. So it's as simple as ABC. So in an electrolytic cell, what happens? The electrolyte is the compound that is decomposed. The compound that is decomposed, the ionic compound that is decomposed. So it's either a molten ionic compound or a concentrated aqueous solution of the ion. So we have the electrolyte. It is the substance, that you pass electricity through and it dissociates or decomposes, or it breaks down into its component ions, because it is a molten state or in solution. Then we have the electrode. The electrodes can be rods, plates, wires made from either carbon, which is graphite, the only non-metal that conducts electricity, or metal, which conducts electricity to and from the electrolyte. So the electrodes are generally poles, rods, or wires, that conduct electricity to the electrolyte and also from the electrolyte. So the anode is the positive electrode, and the cathode is the negative electrode. Then you have the power supply. It must be direct current that supplies electricity. So that is the entire component of the electrolytic cell, where electrolysis takes place. Now this electrolysis of molten sodium chloride, what that means is that sodium chloride is in molten state, in liquid form. So if you electrolyze molten sodium chloride is NaCl. So if you electrolyze molten sodium chloride by passing electricity through it, it is dissociated towards sodium ion and chloride ion. So inside the electrolyte, you have the sodium ion and the chloride ion, which are the only positive and negatively charged ion. So by the time you pass electric current through it, the cation, which is the positively charged ion, goes to the cathode, which is the negative electrode. You can see the sodium ion migrating to the cathode, while the negatively charged ion, which are the negatively charged ion, which are the anions, they migrate to the positive electrode, which is the anode. So at the cathode, this is the equation that will take place at the cathode. Sodium ion goes to the cathode, where it gains electron and becomes reduced to sodium metal, while the chloride ion goes to the anode, where it loses electrons to form chlorine gas. So chloride ion goes to the anode, it loses electron, gives up electron to form chlorine gas. So this is electrolysis of sodium chloride, electrolysis of molten sodium chloride. So inside the solution, you're going to have sodium ion and chloride ions. All the ions will be from the electrolyte. So this electrolysis of molten sodium chloride. So if you look at the electrolysis of molten lead bromide is Br2. So this molten lead bromide, which is the electrolyte. So inside the solution, you are going to have lead ion and bromide ion. These are the ions that will be inside the solution, which is the electrolyte. So by the time you pass electric current through it, the positively charged ions, which are the cations, they go to the cathode, which is the negative electrode, while the negatively charged ions, they go to the anode, which is the positive electrode. So you can see that at this equation that takes place at the cathode, the cations, which is lead 2 ions, they go to the cathode, where they gain electron and become deposited as lead, while at the anode, the bromide ions, they go to the anode, where they lose electron to form to form bromine. So this electrolysis of lead bromide electrolysis of what? Molten lead bromide. So inside the solution, you only have what? Cations, positively charged ion from the electrolyte and negatively charged ion from the electrolyte. So we'll just consider the electrolysis of a molten substance, electrolysis of a molten salt. If the ionic compound is in its molten state, we'll have ions from the electrolyte only, which is positively charged ion, and the negatively charged ion. So the positively charged ion goes to the cathode, while the negatively charged ion goes to the anode. But in a situation whereby the electrolyte is an aqueous solution, so we'll have the electrolyte and we'll have the solvent. So we'll have positively charged ion from the electrolyte and the positively charged ion from the solvent, negatively charged ion from the electrolyte, and negatively charged ion from the solvent. So there will be competition at the cathode, which of the ions will be discharged, whether the ion from the electrolyte or the ion from the solvent. At the anode, there will be competition between which of the ions to be discharged, whether the negatively charged ion from the electrolyte or the negatively charged ion from the solvent. So there are certain factors that have to be put into consideration to determine what the ion that will be preferentially discharged. That's why we have preferential discharge of ions. So in the electrolysis of compounds that contain more than one type of anion or cation, if a compound contains more than one type of anion or cation, one type of the ion will be discharged in preference to the other, which is known as preferential discharge of what? Ions during electrolysis. When you have an aqueous solution of what? Of the compound, you will have more than one type of cation or anion. So that's what we are going to look at, the factors affecting preferential discharge of ions during electrolysis. So we want to look at factors affecting preferential discharge of ions during electrolysis. We consider these factors if we have more than one type of cation or anion competing for discharge. So the first one we want to consider is the position of the ions in the electrochemical series. Now, if you look at what we have the electrochemical series for the cation and the anion, so the negatively charged ion and the positively charged ion. Now, we will talk about position of the ions in the electrochemical series. Now, those ions that are lower in the electrochemical series, for the cations, for the positively charged ions at the cathode, they are those ions that are lower in the electrochemical series. So, if two are positively charged ions, two cations are competing for discharge, the one that is lower in the electrochemical series, that is less electropositive, that's the one that will be preferentially discharged, because such an ion can easily undergo reduction, because reduction takes place at the cathode. So it has a greater tendency for it to undergo reduction, so it can be easily discharged. Then the same thing for the anions. The ion that is lower in the electrochemical series, that is less electronegative, will preferentially discharge, because it has a greater tendency to undergo oxidation, which is lose electron. Has a greater tendency to lose electron for the anions. So if two ions are competing for which of them to be preferentially discharged, the one that is lower in the electrochemical series, that is less electronegative, that is the one that will preferentially discharged. For example, if there's competition between fluoride ion and iodide ion, you discover that since iodide ion is lower in the electrochemical series, it's less electronegative, it has a high tendency to lose electron, it has a high tendency to undergo oxidation. So iodide ion will be preferentially discharged compared to fluoride ion. If there's competition between potassium ion and copper-2 ion, copper-2 ion will be preferentially discharged, because copper-2 ion is lower in the electrochemical series, less electropositive, has a high tendency to gain electrons, have a high tendency to undergo reduction. So the position of the ions in the electrochemical series. So the ions that are lower in the electrochemical series get discharged in preference to the ones above them, both for the cations and the anions. So the concentration of the ions in the electrolyte. This is one of the factors that affect the preferential discharge of ions during electrolysis. Now, the concentration of the solution has an impact on which ions are preferentially discharged. So it depends whether this solution is concentrated or if it is diluted. When we talk about a concentrated solution, that means that solution has a higher concentration of the electrolyte compared to water. So there's less water and more of the electrolyte. But when we talk about a dilute solution, there's more of water compared to the electrolyte. So if a solution is concentrated, the concentration of the ions from the electrolyte will be high compared to the concentration of the ions from the solvent. If a solution is diluted, the concentration of the ions from the solvent will be higher than the concentration of the ions from the electrolyte. So what happens is that the concentration of the ions has an effect on which ion will preferentially discharge. If the two ions are competing for discharge, the ion that have a higher concentration will preferentially discharge compared to the ion that have a lower concentration. Now, the influence of concentration is effective only when the two competing ions are closely positioned in the electrochemical series. The effect of concentration becomes less important as the position of the ions becomes further apart in this series. So what happens is that the rule of concentration only applies when comparing anions, especially in solutions containing the halides, and does not usually apply to the cations. So in general, the concentration of the ions in the electrolyte can affect the ion that will preferentially discharge. The ion that have a higher concentration will preferentially discharge compared to the ion that have a lower concentration. So we say the effect of concentration only comes into play when the two competing ions are closer to each other in the electrochemical series. But once they are further apart, the effect of concentration is less important, cannot come into play at that particular point in time. So any other factor, which is the position of the ions in the electrochemical series, will determine the ion of preferentially discharge instead of what concentration of the ions in the electrolyte. Concentration only affect the ion of preferentially discharge when the two competing ions are closer to each other in the electrochemical series. But when they are far apart, the effect of concentration cannot come into play at that particular point in time. Now, the next one is the nature of the electrode used. Yes, the nature of the electrode used can affect the ion that will preferentially discharge. If two ions are competing for discharge, the nature of the electrode used that can affect the ion that will preferentially discharge. What happens is that if one of the ions have characteristics similar to that of the electrodes that is used, or maybe the electrodes have affinity for any of the ions that are competing for discharge, that ion can be preferentially discharged. Now, some electrodes that have a strong affinity for certain ions may influence ionic discharge. For example, in the electrodes of sodium chloride, if we use platinum electrodes, there will be competition between sodium ion and hydrogen ions. Hydrogen ions will be preferentially discharged. But if we use a mercury cathode instead of platinum, if we use a mercury cathode instead of platinum, sodium ions will be preferentially discharged because the mercury will tend to associate with sodium ions to form sodium amalgam, so that the discharge of sodium ions require less energy than that of hydrogen ions. Other electrodes which possess characteristics, just as I've explained, similar to those of the ions in the electrolyte, may also influence ionic discharge. If a copper anode is in the electrolysis of copper sulfate, neither the sulfate nor the hydrogen ion will be discharged. Instead, the copper atom from the anode go into solution as copper 2 ions, because these atoms will give up their electrons more readily. So the nature of the electrode used can affect the ions that will preferentially discharge. So this is one of the factors that affect the preferential discharge of ions during electrolysis. So we have the position of the ions in the electrochemical series, the concentration of the electrolyte, and the nature of the electrode used. So the nature of the electrode used can also affect the ions that will be preferentially discharged if there's competition between two ions, which will be preferentially discharged. So thank you for listening. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Feel free to reach out to me, share, comment, and reach out to me if you encounter any difficulty or you need extra explanation. Please feel free to reach out to me. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you for listening once more. Make sure you subscribe, share, comment, like, and reach out to me if you encounter any difficulty.